So let's talk about a puzzle that pretty much every organization faces. How do you actually know who's performing the best? Whether you're looking at a warehouse, a sales team, or even a hospital, the ways we usually measure efficiency can be super misleading. We're going to break down exactly why.
And that's really the big question, isn't it? It feels like you should just be able to look at the data and see a clear winner. But what happens when the numbers start telling you different stories? As you're about to see, that happens way more than you'd think.
You see, the way we usually try to judge performance is by breaking it all down. We measure things like productivity, cartons handled per hour. Then we'll track response time, we'll look at costs, we'll check accuracy. But each of these numbers gives us just one little snapshot. And often, those snapshots totally contradict each other. Now, the fancy term for these things is key performance indicators, or KPIs. They're the standard tool for the job, right? You just take an output, you divide it by an input, and boom, you get what feels like a perfectly logical, common sense number. But this is exactly where the puzzle starts to get tricky. Because that super logical method, well, it can lead us straight into what we're calling the KPI trap, a place where all those simple comparisons completely fall apart, and finding out who's the best becomes almost impossible. Okay, take a look at this. We've got 3 warehouses, each scored on 3 different KPIs. We've put the scores on a scale from 0 to 1, where 1 is the best. Just looking at this, take a quick guess. Which one is the top performer? It's not so obvious, is it? Let's try to work it out step by step. Okay, first up, let's compare Warehouse A and Warehouse B. A is better on KPI 1 and KPI 3, and it only loses out on KPI 2. So by a simple 2 out of 3 vote, it seems pretty clear. A is better than B. Makes sense, right? Now let's apply that exact same logic to B and C. Warehouse B scores higher than C on KPI 1 and KPI 2. Again, 2 out of 3. So we've built this logical chain. A beats B and B beats C. It really feels like we've got our answer. But hold on a second. This is where the trap springs. If we compare C back to our supposed winner, A, something really weird happens. C actually beats A on KPI 2 and KPI 3. That's right. Using the exact same logic, C is better than A. What just happened? We've gone in a complete circle.
So who's on top? A is better than B, which is better than C, which is somehow better than A. It's a total paradox. This is the KPI trap, and it shows the huge fundamental flaw in trying to compare performance with a bunch of simple ratios. It's why we need a much better way to see the whole picture.
So how do we get out of this mess? Well, we can't just average the scores or try to weigh them differently. We need a completely new way of looking at it, a way to stop looking at all these disconnected little numbers and start understanding the entire system at once. What that means is shifting from that ratio-based view to a systems-based view. We stop asking who's the best at this one specific thing, and we start asking a much, much more powerful question. Who is the most efficient at turning all their resources, labor, capital, the whole shebang, into results? So how does that actually work in practice? The whole key here is making a fair apples-to-apples comparison. Look at Warehouse A and C here. C produces more output, sure, but it's also using different inputs. So to compare them, we can mathematically scale Warehouse C down, creating this hypothetical Warehouse C prime that produces the exact same output as Warehouse A. Now we can finally see what resources each one would use to do the exact same job. And bam, the power of this way of thinking becomes crystal clear. Once it's scaled, we see our imaginary Warehouse C prime produces the exact same output as Warehouse A, but it does it using only 72% of the labor and 72% of the capital. All that confusion is gone. It's obvious. Warehouse C's process is just plain more efficient. Okay, that's great. But what happens if no single competitor is just flat out better on every single thing? Well, this is where things get really, really clever. We can take this whole scaling idea and use it to build a hypothetical super warehouse that acts as the ultimate benchmark. There's a powerful technique for this, and it's called Data Envelopment Analysis, or DEA for short. Instead of comparing a warehouse to just one of its rivals, DEA compares it to a synthetic ideal benchmark. And this benchmark isn't pulled out of thin air. It's created by blending the best parts from a whole group of its real-world peers. Here's the 5-step recipe, basically. First, you pick the warehouse you want to evaluate. Simple enough? Then, you scale all of its peers to match its output.
That's our apples to apples step again. Now here's the magic bit. You don't pick just one peer. You blend the best features from all of them to create a synthetic, best-in-class benchmark. From there, it's easy to calculate one single definitive efficiency score. Let's make this real. Say we're looking at warehouse A again, this time against two scaled peers, E prime and F prime. See the issue here? Neither one is a slam dunk winner compared to A. E prime is awesome on capital, but uses way more labor. And F prime is a rock star on labor, but it's weak on capital. A simple comparison just leaves us stuck again. But here's the genius of DEA. We don't have to choose. We can create a hypothetical benchmark that takes the low capital advantage from E prime and combines it with the low labor advantage from F prime. We're not comparing A to a real place anymore. We're comparing it to a perfect blend of what's actually possible, based on the best practices that are already out there. And what's the result? Well, this synthetic super warehouse proves that warehouse A is at best only 72% efficient. This imaginary warehouse achieves the same output as A, but with only 0.72 of the inputs. We've totally escaped the paradox and found one single meaningful score that tells us exactly how much room for improvement there really is. Okay, so this is a really powerful analytical tool, right? But what does it actually tell us about the real world? Well, a major study at Georgia Tech used this exact method and uncovered some very, very surprising lessons about what really drives efficiency. Get this, the conclusions from that study pretty much fly in the face of conventional wisdom. First, they found no real efficiency difference between union and non-union places. Second, warehouses that spent less money on high-tech automation often did better than those that spent a ton. And maybe the most surprising thing of all, smaller warehouses were generally more efficient than bigger ones. Yeah, that last point is so wild it's worth highlighting with this direct quote from the study. Pure size hurts efficiency. And the logic behind it is actually pretty simple. If you just make a building bigger to hold more stuff, you're also creating more travel time for your workers, which just makes the whole operation less productive. So this really boils down to a choice. There are two paths to growth. You can just get bigger by scaling up, which, as we've just seen, can actually make you less efficient. Or you can get smarter. This means using that bigger scale to fundamentally change your processes, like handling bigger pallets or using automation way more effectively, like companies such as Walmart have done. That's where you find the real efficiency gains. And that really leaves us with one final big question to think about, one you can apply to any team or any business. As it grows, is it just getting bigger, or is it using that growth as an opportunity to get smarter?